So thank you for introduction and thank you so much for coming here. So today I am going to talk about a really well-known topic of layer twos. A lot of you might be very familiar with the topic about rollups and how rollup works, how different types of rollup works. But for those of you who are not, I'm going to explain how rollups work and what are different kind of rollups. So, just a brief introduction about myself. Hi, I am Sahil Sen. I work at QuickNode as a senior developer advocate, and I work on creating a lot of educational content. It's around videos, it's blog posts, documentation, and all that kind of stuff. So, for those of you who doesn't know what QuickNode is a Web3 development platform, and we provide a lot of different tools to make lives of developers easier. So let's start. So basically, what's Ethereum's vision is to create a blockchain which everyone can use without any hurdles. But since its inception, it has been the number one blockchain network, and everyone has been using it for like basically everything. So because of that, the space or the block space of Ethereum has become really expensive, and the gas fees have skyrocketed. So, because of all of this, the transactions are queuing up a lot, and the total finality time of transactions a lot of times as if they are sent with less gas. So this all relates to a concept called blockchain trilemma, where each edge is a feature, you can say, for blockchain. It's scalability, decentralization, and security. So right now, Ethereum is very much decentralized and secure, but it has been having scaling issues for a really long time. So the blockchain trilemma states that at any given point of time, a blockchain network can achieve only two of this. So it can be either on the edge A, B, or C. But an ideal blockchain would look like where it can stand right in the middle, where it's enough decentralized, it's enough secure because it's fairly decentralized, and then it's scalable as well. So an ideal blockchain would look like that. But since it's not ideal at the moment, so there are some scaling solutions which have been discussed in the past and which are already in the works and which are already working right now. And that's layer 2 scaling. So layer 2 scaling is basically scaling Ethereum off chain by not scaling the actual Ethereum chain, but by settling transaction of the chain. And are two types of layer 2 solutions, rollups and state channels. So basically what rollups does is they settle the transactions of the chain, usually on a different chain, and then they roll up the transaction information in a batch on the main Ethereum chain, usually using a smart contract. And what state channels are? State channels does the same thing. They settle the transactions of the chain, but they do not send the entire transaction information as a batch on the chain, but what they do is they open a state channel of the chain, which is usually a multi-sig smart contract, and only two transactions are used for the main Ethereum network. The one is to open the channel, the other is to close the channel. In the state channel, there are like multiple parties who agrees on a transaction because it's a multi-sig contract, who agrees on a transaction, and then the transaction is completed. So state channels cannot be used practically because they are highly application specific. For example, there are payment state channels right now where if someone wants to send a transaction in forms of tokens, what they do is they will open a multi-sig contract, and when both the parties who are predetermined will sign the transaction, and then only that funds will move out of that wallet. So rollups is very, like, I would say, um, practical at this moment. So there has been a lot of development around rollups, and basically rollups are of two types. The first one is optimistic rollups. Optimistic rollups can be considered as kind of an angels of the blockchain, where they consider that, or they consider every transaction which is being verified is valid, and there is no fault in that. So in optimistic rollups, there is a batch maker or a batch submitter. What they do is they submit the transactions which has been happening on a side chain or a layer 2 chain, and they create a batch of those transactions and submit the information batch on the main Ethereum chain. And now you may ask that, okay, so if what if there is a fraudulent transaction in that? So because to encounter that, there is a third party called for fraud proof submitter. What they do is they identify the transaction which can be considered a fraudulent transaction, and then they submit a fraud proof. So both of these parties who are submitting the transaction batch and fraud proof, they stake their coins, and if any of the party is found guilty, their coins or ETH are slashed. So once the fraud proof is submitted, that particular transaction is rerun on the main Ethereum chain. And if the transaction is found guilty or fraud, then the fraud proof is approved and the batch submitter gets the ETH slashed. So this is how optimistic rollups works, and they're easy to implement because they don't require a really complex cryptographical framework beforehand, because they only need fraud proof submitters and batch submitters. And then next type of rollups technology is zero knowledge proof rollups. So what zero knowledge proof does is it overcomes the assumption of a transaction being valid, but they actually validate the transaction using zero knowledge proofs. Zero knowledge proofs are nothing but uh, your cryptographic proofs which are generated and which validates a particular transaction without revealing much information about the transaction to other third parties. And in zero knowledge proofs, the transactions are validated beforehand and then they are submitted on the main Ethereum chain. So because they require a complex cryptographical framework beforehand, that's why they are kind of complex to implement, and it has become really difficult for anyone to make a zero knowledge proof Ethereum compatible. But now we are seeing a lot of different players coming in and making zero knowledge proof compatible Ethereum chains like Polygon ZK VM. And then there are few challenges as well. Implementing layer 2 chains or layer 2 technologies. The first and the most critical centralization. So because these chains are very scalable and they submit their transaction information on Ethereum, that part is fine, but how transactions are verified and validated on these layer 2 chains is with the help of a sequencer. So this sequencer is just one centralized entity, and if this particular entity gets manipulated or if this particular entity gets bought down, the entire chain can be compromised and be halt. And then, as we saw with ZK proof or zero knowledge proofs rollups, it's pretty complex to implement. So the complexity is also a constraint, and migration is another constraint because these are different chains. These are not the main Ethereum chain. So the funds need to be migrated from one chain to another. And we all know that we have to use bridges for that. And the experience to use bridges is not that good. And they can get compromised a lot of times. And then the other point is interpolability. So the interpolability means interpolability of the data between one chain to another. So these chains have really good interpolability between that particular chain and Ethereum, but the interpolability between one L2 to another L2 is not that great, and all of this results to a bad user experience for an end user. So that's what like the challenges to implement layer 2 solutions looks like. And this was a really short presentation for everyone who did not know what layer 2s are, but looks like a lot of you know. And the implementations or the best implementations for the optimistic rollups, according to me, are Arbitrum and Optimism. They have been doing a really great job at implementing layer 2s using optimistic rollups, and using Polygon ZK EVM recently came up, and it's completely or fully Ethereum compatible. So all the smart contracts which we have on Ethereum can be ran on that particular chain as well, without or with like less like anomalies. And then ZK Sync is working on their Ethereum compatible chain as well, which is ZK Sync Era. So yeah, this was it from my presentation. And if anyone has any questions, now will be the time to ask. And if you all want to connect with me, I am Sen Sahil on Twitter. And if you're a new hacker and want to check out new materials or new tutorials, we have a YouTube channel where we post regular content every week for to help people build different kind of applications. So thank you, everyone.